This is the unit number 4, or we can say first unit in a section 2. The title of this is the disposal of wastewater. Until now, section 1 is one little much heavy as compared to the section 2. So almost section 2 can be covered very easily, but section 1 is very heavy. So it takes a lot of time. Unit number 4, disposal of wastewater. In that you are going to study disposal of wastewater, stream pollution, self-purification, dissolved oxygen sag curve. It is usually known as DO sag curve. Very interesting, this chapter. Then Streeter-Phelps equation. Then emerging technologies for wastewater treatment, centralized sewage treatment system, objectives of small and decentralized wastewater treatment system. Under that, decentralized wastewater treatment system, we are going to study some new technologies, that is root zone technology, constructed wetland. Yeah, just now in the last chapter we talked about the wetland, and what is exactly that wetland that we are going to study in this chapter under the constructed wetland point. And then duckweed ponds, and then fluidized aerobic bed technology and UASC. Okay, so these are the points we are going to study in detail under the chapter number 4, disposal of wastewater. So the first part we will start immediately. The methods of disposal of wastewater may be classified under the following categories. So before I start this point, I want to give some backgrounds. Okay, disposal of wastewater. We are focusing on the disposal of wastewater. But what type of wastewater disposal? Wastewater generating from the municipal area, industrial area, commercial activities. We are supposed to provide the treatment to these types of wastewater separately, and then you can send it to disposal. Okay, so after waste treatment also, we need to dispose that water in a proper manner. Otherwise, it will create the unhygienic environment. So there are the multiple ways to dispose that wastewater. Sometimes we are providing treatment to this water and then we are disposing it. Sometimes without treatment also, that is being disposed. So still, if you are not providing treatment, there are some rules and regulations that you need to follow. So that is what discussed under this point. So the methods of disposal of wastewater, this can be classified under the following categories. So what is the categories? First category is the natural method. First one, in that natural method, there are two ways. One is the dilution by dilution method, and another one is the by land treatment method. So natural method in the sense after the treatment or before the treatment, whatever is the possible. So the wastewater simply you can mix into the river water body. So river water body is having huge amount of water, clean water already in this body. And in that, a small quantity of sewage you are adding. So you are diluting that sewage by adding it into the good amount of clean water. That is by dilution. Okay. And another one is by land treatment. So for that land treatment, you can dispose it on the land and let it get filtered out, percolate into the ground. While percolation itself, it is getting treated. Okay. So likewise, when you are disposing into the river, along with that river water, it is also flooding and mustarding. And by natural method, it is getting treated in the river itself. That is known as the by dilution method. Then the second one, by artificial method. So here, there are two ways. One is the primary treatment and secondary treatment. Artificial in the sense, whatever we have studied until now in the chapter number 2, 3. So there are the treatments. So artificial method, if you are providing artificial method, you need to provide the primary treatment, or you need to provide primary and secondary treatment together. So there are the norms which can be allowed to dispose after what condition. There are the norms. That norms also we are going to discuss further. So under artificial method, you can say either you can need to provide the primary treatment and then dispose, or you need to provide primary and secondary together and then dispose. Okay. Then the combined methods. In the combined methods, again, there are two ways. One is the primary treatment and second one, effluent disposal by natural methods. You provide the primary treatment and dispose it by the natural methods, either by dilution or by land treatment. So if together used, it can be called as the combined method. Okay. So these are the various. So first of all, write down the title of this chapter. Unit number 4, disposal of wastewater. Write down, please. Have you written title? Unit number 4, disposal of wastewater. Under that, the methods of disposal of wastewater, you can just simply these three types, that is natural method, artificial method, and combined method. Quickly. Done? Okay. Now there are two general treatment objectives. What are the
backslide?
Okay. Jadi panian tuh
Done, ma'am. Thank you.
good. Thank you. Now, what are the objectives of with respect to wastewater treatment? Okay, why we need to go for this properly? Reducing or minimizing the public health hazards of wastewater. Anyone can say that. These are general treatment measures aimed at preventing pathogens. If you don't follow the protocols for the disposal of wastewater or the collection of wastewater properly, then there will be an entire environment will convert into unhygienic by the growth of pathogens and bacteria and microbes anywhere. And other potentially harmful components from finding their way back to the consumers. Okay. So eliminating and reducing and minimizing the deteriorative impact of wastewater on the receiving water quality and its environment. Okay, if you don't dispose it properly, if you don't withdraw it properly from the particular city, it will start mixing into the water source, and then it will deteriorate the quality of water source which we are using for the drinking water purpose. So that will be a greater impact on the receiving body. So that's why it needs to be done properly. Now we are talking about this method. By the natural method, if you are disposing the wastewater by dilution into a particular stream, at that time there will be a self-purification process will be performed. So what is that exactly self-purification process that we are going to study in detail over here? So in the first short, I have given you the background or the definition in short, you can say, about the self-purification. The self-purification of natural water system is a complex process that often involves physical, chemical, and biological process working simultaneously. The amount of dissolved oxygen in water is one of the most commonly used indicator of a river health. As DO drops below 4 or 5 milligram per liter, the forms of life that can survive begin to be reduced. So I will share with you guys one in this regard I will share with you my own video, and I request everyone to watch that video for some time. Just give me a few seconds. Let me open my channel first. My channel I'm not able to finding. Give me a second. So here you can see playlist, and in that videos. This one. Just a few seconds. Perfect one I will show you. Introduction to disposal of wastewater is the perfect one. Is it audible, guys?
No, ma'am.
No. Huh?
No, ma'am.
Okay, I will share that link and will ask you to go through this within 10 minutes. This is a 10-minute video. Very clearly, it is explained with pen and paper. So please go through this and come back. You can. Okay. So I will share on group. Quickly, you can watch this in a 10 minutes. So that concept you will understand better in that. Take a look fast. Is it reached to you?
No, ma'am.
No, I shared on the group. Check on group. Snehal.
Yes, ma'am. Just reach.
Okay. So watch this video in a 10 minutes and then we'll continue. Okay. So everyone will be back after exactly after the it's 11:15. At 11:25 we will be back here. So if you need to leave this, if it is not required, don't leave. If it is required, you can leave and watch that session. Please fast. I hope everybody has watched that video, whatever provided, which is giving entire background of this chapter. So very important point was there. And if you understood through that video, 10 minutes video, short videos, I have prepared to make easy to the guys. Yes, Swapnil, have you watched that video? Swapnil Dhokate, have you watched? Yes or no? No answer means not watched. Huh? Who watched? I will not worry much, guys, because if you are not worrying, why I should worry? But you should take these steps. Rutuja Shirke watched. Have you enjoyed, Rutuja? Was it informative and giving entire background of this chapter? Rutuja, or is there any lacunas you observed? It was you enjoyed that. Okay. Anybody else? Anybody else? Some may be still watching. Akanksha Chaure, what is your review? What you did, guys, in a 10 minutes, if you have exclusively given to watch that video? What you did, guys? Snehal, I too saw the video. What is your opinion, Snehal? Understood the background of this chapter?
Yes, ma'am.
Okay, good. Anybody from boys' side? Anybody from boys' side? No, they don't wish to go and take attention much. Okay, no problem. We'll move for the next point. So this was very interesting and informative video I shared with you guys. Let us come back to your session. Yeah. Now we'll continue the same. So with this video, I assume that with this, I assume that you understood the background of this chapter, and now we will talk about the self-purification process. How this water is getting self-purified with the existing flow that we are going to learn. Okay, self-purification. It is a natural process, and in that chemical, physical, and biological processes are performing together simultaneously. And what is the indicator used whether the process is functioning effectively or not? That is the dissolved oxygen, level of dissolved oxygen. If the level of dissolved oxygen is dropping down, it indicates that there is no self-purification performed. If the level of dissolved oxygen is increasing, it indicates that the level of the self-purification is performed well. Okay. So usually for any water body, if aquatic plants and aquatic animals are surviving, there is a requirement of 4 to 5 milligram per liter DO, and maximum, or we can say saturation level of dissolved oxygen is in between 14 to 15 milligram per liter in any water body. Okay. Now, so further we will discuss much about a minimum of about 2.0 milligram of dissolved oxygen is required to maintain the higher life forms. Okay, त्याच्या खाली जर गेला तर there will be it will start killing the aquatic plants and aquatic animals in the body. Okay, So what are the number of factors affect on the amount of dissolved oxygen available in? Okay, I got disconnected because of network issue. So I'm back. Yes, guys, you can watch this one here. Plants are add during plants are keep on adding dissolved oxygen during the night. This photosynthetic activity are being performed and then it is releasing oxygen. That way plants are also adding dissolved oxygen level. Atmospheric oxygen is also being added in natural method. And usually in a summer, rising temperature reduces the solubility of oxygen. Okay, if temperature increases, the dissolved oxygen starts escaping. Means the solubility of dissolved oxygen in that particular body reducing. So the dissolved oxygen ratio depends upon the temperature. Temperature increases, dissolved oxygen rate of dissolving oxygen decreases. If temperature decreases, the rate of dissolving oxygen increases. Okay, remember that. While lower flows reduce the rate at which oxygen enters the water from atmosphere. Okay. So what are the different factors that affecting on the dissolved oxygen or the cell purification process? So they are the cell purification process in the sense naturally the water is getting treated by the natural method in any kind of water body. It may be a stagnant water body, it may be a running water body. If a stagnant water body, their phenomena will be different, and if it is a running water body, their phenomena will be different. So what are these factors affecting on the cell purification process that we will see in detail? So the first guys, network is crashing intermittently. I will take care. So I was talking about the factors affecting on the cell purification, whether the body is a running water body or whether the body is stagnant water body. That is the different issue. What is meant by running water body and what is meant by stagnant water body, that you have learned through the earlier video, whatever I shared with you, and for the 10 minutes. So we will talk what are these different factors. So the first and important factor is the dilution factor. So dilution in the sense when you are adding sewage into in a particular water body at that time, whether this performing that performance depends upon the ratio of dilution. Okay, when sufficient dilution water is available in the receiving water body, म्हणजे जर त्या receiving water body मध्ये sufficient quantity of water is available, then dilution performs well. If not sufficient quantity, म्हणजे जो येणारा फ्लो आहे सिवेजचा तो 10 mld आहे आणि ह्याच्यामध्ये जे फ्लो आहे तो 2 mld आहे, whether that dilution is functioning? No, it should be always greater and sufficiently greater, 10 times greater. Where the wastewater is discharged, the DO level is in the receiving stream may not reach to 0 or critical due to availability of sufficient oxygen initially in the river water body before receiving discharge of wastewater. Means what I have discussed in the video, whatever shown with you, but still those who have not watched, I should take care for them also. So in short, I will show you, this is a river and this is a spot where you are disposing the sewage. Okay, so if that body is having sufficient quantity of water and where you are disposing the sewage, in that case, immediately at this portion, it will start decrease. It will not start decreasing the dissolved oxygen level. This graph I have shown the level of dissolved oxygen. At this point, you will not find that the dissolved oxygen is getting down, but slowly the dissolved oxygen will keep on degrading. But if sufficient quantity is not available in this stream and you are disposing sewage into that stream, means there is no sufficient dilution ratio. In that case, immediately the dropping of dissolved oxygen will form like this. Critical, it will reach to the critical dissolved oxygen. So for that purpose, you need to confirm whether the amount quantity of water is available with a good quantum in the existing water body where you are going to send or dispose the sewage. Okay. Now, the second one is the current. When strong current is available, the discharged wastewater will be thoroughly mixed with the stream water, preventing deposition of solids. In small current, the solid matter from the wastewater will get deposited at the bed following decomposition and reduction in DO. So you can see here like this current, if sufficient current studying water is available, is strongly studying the water, in that case, it will fast mixing of oxygen, rate of mixing of oxygen is very fast. And if that water is slowly and steady, then in that case, there will not be the sufficient quantity of dissolved oxygen mixing performs in that particular body. So current matters. आणि करंट कधी जास्त असू शकतो जेव्हा स्लोप टू दॅट पर्टिक्युलर वॉटर बॉडी इज व्हेरी हाय अँड or sometimes the quantum is very good and the water is sturdy. In that case, current will be good to the existing water body, and if current is good, the rate of dissolved oxygen mixing will be good and the degradation process performs with a faster rate, and the quantum of that sewage getting self purified vary with a faster rate. Okay, so when a strong water current is available, the discharged wastewater will be thoroughly mixed with stream water, preventing deposition of solids. In small current, the solid matter from the wastewater will get deposited at the bed following decomposition and reducing the reduction in DO. What is the third factor? That is temperature. The quality of DO available in stream water is more in a cold temperature. As I said just now, it is the rate of dissolved oxygen increasing. It depends directly proportional to the temperature. If the temperature increases, DO level decreases. If temperature decreases, DO level increases. So the temperature directly proportional to the level of dissolved oxygen in that particular body. So the quality of DO available in the stream water is more in cold temperature than in hot temperature. Also, as the activity of microorganism is more at the higher temperature, hence the cell purification will take less time at hot temperature than in the winter season. So very interesting twist is here. So if the temperature increases in that water body, there is a chance to have the rate of decomposition with a faster rate because it is converted into thermophilic environment. And I have already mentioned to you how the bacteria functioning in respect of temperature. Okay, so if temperature increases, means during the thermal temperature, usually thermophilic stage, that is 35 degrees Celsius to 55 degrees Celsius, the decomposition of organic waste material by the microorganisms performs with a faster rate. Means if the temperature during summer season is increasing and DO level decreasing, but the microorganisms are functioning effectively for the degradation process and will help to perform the cell purification process. Okay, so in that way, two-way action. And during winter season, if there is a because of no temperature, less activity of microorganisms are observed, but sufficient oxygen is provided, and hence the decomposition is performed. Okay, then sunlight. Algae produces oxygen in presence of sunlight due to photosynthesis. Therefore, sunlight helps in purification of steam by adding oxygen through the photosynthetic activity. Also, if the layer of this water is very thin and there is a sufficient sunlight, naturally disinfection is also being performed due to sufficient sunlight in that area. Then the rate of oxidation, due to oxidation of organic matter discharged in the river, DO depletion occurs. This rate is faster at higher temperature and low at lower temperature. Okay, remember that twist. Due to oxidation of organic matter discharged in the river, DO depletion occurs. This rate is faster at higher temperature and lower at a low temperature. The rate of oxidation of organic matter depends upon the chemical composition of organic matter. If it is very complex, it will take a lot of time. If it is simple form of organic matter, it will get degraded easily. Okay, so rate of oxidation is also one of the important parameter affecting on the cell purification process. Okay, so these are the various factors affecting on the cell purification process. I request everybody to write down the heading factors affecting on the cell purification process and only note down the titles. That is, first one is the dilution, second one current, and then third one temperature, sunlight, and rate of oxidation. So please do this one. So time being, I will note down your attendance, and then after that, I will ask you to leave this class for today.
Recording in progress.
Okay, next 2 points, you please, next 3 points, temperature, sunlight, and rate of oxidation, note down. Copy this one, and those who have finished, they are allowed to leave as the session is over for today. We are stopping over here. If anybody have question, they can ask me.